This is the experimental Windmill sailing craft being tested. The wind turbine or rotary sail was mounted on a 12-foot catamaran and was connected to an underwater propeller by belts, which changed the gear ratio to increase the speed to the propeller by about 3 times. After many practical tests on models, I was able to decide which was the best design of rotary sail to use for going directly into the wind. I found that the best angle of pitch for the rotor blades was 45 degrees to the wind when stationary. At this angle the blades rotate at the same speed as the wind, tip speed ratio of 1. This is a very slow rotation speed compared with the type of wind turbine used on land. There are several advantages to this. The stresses on the blades are much lower than on a land wind turbine and therefore can be made much lighter. These ones were made of balsa wood and based on the model aircraft wings. Due to the low rotational speed, there are no gyroscopic effects. Because I used a belt drive which could not be twisted beyond a certain point, the wind rotor assembly was not able to rotate fully 360 degrees and therefore needed to jibe when passing through the wind with the wind from behind. It would do this automatically. To be able to control the wind rotor and stop it if needed, it was necessary to make a pitch control mechanism. Using this, I found that stops and starts of the rotor were nearly always instantaneous. Because the rotor trails behind the vertical pivot point, the whole assembly weathercocks into the wind automatically and is balanced by a counterweight on an arm which projects out in front and always points to where the wind is coming from. You can check the speed of the rotor by watching the black stripe on the end of one of the wind blades. It may seem surprising to learn that a wind-driven craft can be powered directly into a headwind, but check out further information by visiting the website in the credits at the end of the video.